Good morning. Today we're going over our first homework assignment for ions and ionic compounds. And for this first problem, we're looking at forming ions. And so I've got my periodic table handy, and we've got this first problem where we're looking at what kind of ions will a certain element choose, and then what type of electronic configuration we can expect. So in the first case, we're looking at magnesium, and magnesium's here, it's in group 2, and that tells us that it has 2 valence electrons. And when we're forming ions, the goal is to have the same number of electrons as the closest noble gas. So here are the noble gases. Neon has 10 electrons, argon has 18. And if magnesium could get either 10 or 18, then it will have the same electronic configuration and therefore the same electronic stability as either of these. 12, as you might note, is closer to 10 than it is to 18. So it would be easier for magnesium to become like neon by losing 2 electrons. That would give it a positive 2 charge. So magnesium will lose 2 electrons. Next, we're comparing each of these ions to helium, which has 2 electrons, neon, which has 10 electrons, and argon, which has 18 electrons. Oxygen 2-, when it gains 2 electrons, will be like neon. It will have the same number of electrons as neon. Beryllium 2+, beryllium already has 4, so if it loses 2 to become 2+, it would only have 2 remaining, which means it would be like helium. Nitrogen 3-, nitrogen has 7, so if it gains 3 to have a -3 charge, it will have 10, like neon. Sulfur 2-, sulfur has 16, so if it gains 2 to have a -2 charge, it will have 18, just like argon. Lithium 1+, lithium has 3, so if I lose an electron to gain a positive charge, then I will only have 2 electrons left, just like helium. Chlorine-, chlorine has 17 electrons, so when it gains 1 in order to get a negative charge, it will have 18, just like argon. Sodium 1+, sodium has 11, so if it loses 1 to form a charge of +1, it will have 10, just like neon. And calcium 2+, calcium has 20, so if I lose 2 electrons in order to get a positive 2 charge, then I will have 18 and be just like argon. For atoms or elements that have the same number of electrons, they have the same electronic configuration. All right, main group elements that are nonmetals. Nonmetals are over here, this side. They usually gain electrons to be like closest noble gases because they're closer to this side of the periodic table. So they're going to gain electrons. That makes them negatively charged ions, which are called anions. So they gain electrons to form anions, and anions have a negative charge. So gain anions, negative. An element belonging to the halogen family, that's this group 7 here, fluorine, chlorine, bromine, iodine, would be expected to have a large ionization energy and a large electron affinity. Ionization energy and electron affinity both increase as we go across the periodic table. They increase as we go up, so they increase going this direction. So fluorine has the highest electron affinity and the highest ionization energy, and francium would have the lowest. Now, just as a reminder, ionization energy is the energy that you have to put into something to remove an electron. That is the energy you have to put in to create a cation. So fluorine doesn't want to give away any of its electrons. It wants to keep all of them, and it wants more. So it has a very high ionization energy, with contrast to, say, sodium, which is happy to give away its electron. It's very easy to do that. So fluorine doesn't want to give away its electrons. In fact, it wants to gain more. So it has a high affinity for additional electrons, as opposed to sodium, which has a very low affinity for additional electrons. It kind of doesn't know what it would do with those. It wants to get rid of the one that it has, and it doesn't want any more. So a large ionization energy and a large electron affinity. The symbol for the ions that we would get, chlorine ion would have the chlorine atomic symbol plus superscript, a -1 charge for the chlorine ion. Calcium, we use the calcium atomic symbol on a 2+ charge because it's in group 2 and it wants to lose 2 electrons. Sulfur is in group 6. It has 6. It needs 2 more. So it will have a -2 charge. Aluminum is in group 3. It has 3. So it actually loses 3 so that it has the same number of electrons and electronic configuration as a neon. That's easier than gaining 5. Next, name polyatomic ions, and these are polyatomic ions which are listed in your lecture notes. Under Introduction to Ions, we have the main group ions, which we just covered. And then we have polyatomic ions, and here's your chart that you need to memorize. So the SO3 2- is the sulfite ion. You can call it the sulfite ion, or they just want sulfite. CO3 2- is the carbonate ion. Carbonate. CrO4 2- over here is the chromate ion, or chromate. And NO3- is the nitrate ion, nitrate. Now going the other direction, if they gave you the name of the ion, they want you to provide the symbol. So the carbonate ion is this one right here, CO3 2-. CO, make sure that that 3 is your subscript and that you've got 2- as your superscript. And you don't want those stacked, right? So when we've got hydroxide, which is OH-, we're going to use this superscript. Hydrogen phosphate is HPO4 2-. HPO subscript 4, superscript 2-. And sulfate, SO4 2-. In case anybody's wondering, I'm using the keyboard shortcuts to get to the superscript and the subscript. If you wonder what those keyboard shortcuts are, and they've got them for many common operations, you can click on this little button and it'll tell you. Next, determine whether the following pairs of elements can form ionic compounds. And what we find is that when you have metals reacting with nonmetals, you get ionic compounds. Whereas you have nonmetals reacting together, then you would not get an ionic compound. It would get a covalent compound instead. So fluorine and sodium, fluorine is a nonmetal and sodium is a metal. So yes, ionic compound. Oxygen and magnesium, oxygen is a nonmetal, magnesium is a metal, ionic. Iron and chlorine, iron is a metal, chlorine is a nonmetal, so ionic. Potassium and sulfur, I have potassium, metal, sulfur, nonmetal, so yes, ionic. Lithium and calcium, lithium's a metal, calcium's a metal, uh-oh, no dice. Nitrogen and iodine, nitrogen is a nonmetal, iodine's a nonmetal, so not ionic. And next, what is the formula for an ionic compound that contains the elements calcium and fluorine? Here you have to notice that the ionic charges must cancel. If I have a charge, I am an ion, but a compound must be neutral by definition. If I'm not neutral, then I'm still an ion. So if I make a compound between calcium, which wants to be +2 because it's in group 2, and fluorine, which wants to be -1 because it's in group 7, calcium +2, fluorine -1, I'm going to need 2 fluorine ions for every 1 calcium ion in order for the ion charges to cancel. If I put 1 calcium at +2 and 1 fluorine at -1, I would still have a positive charge, so that wouldn't work. If I put 3 fluorines, I would have +2 and then 3 negative ones. That would have an overall negative charge. That wouldn't work. You have to use a formula with exactly the right ratio in order for the whole thing to be neutral. CaF2 is it. Which of the following pairs of elements are likely to form ionic compounds? Okay, again, potassium and sulfur. Potassium's over here, sulfur's over here. Non-metal, metal, yep. Sodium and potassium, right here, two metals, nope. Helium and oxygen. Helium's a non-metal, so is oxygen, so no. Nitrogen and oxygen, here they are, both non-metals, so no. Chlorine and bromine, both non-metals, no. Magnesium and chlorine, magnesium's a metal, chlorine is a non-metal, so that works. All right, so for this problem, we're forming ionic compounds, and again, they give us the ions with the charges, and the whole point is to cancel those charges out. So for example, if we have Al3 plus and Cl minus, then we have 3 positive charges and 1 negative charges. I'm going to need 3 of those in order to balance one of these. So if I put that together, it will have the formula AlCl3. And for calcium plus 2 and sulfur minus 2, the charges cancel. One of these is equal and opposite to one of those, so I just need 1 of each. For this one, I have lithium with a 1 plus and sulfur with 2 minus, so I need 2 lithium ions to balance the S charge. So it's going to be Li2S. With potassium plus 1 and nitrogen minus 3, I'm going to need 3 potassiums in order to get 3 positive charges to cancel out the negative 3 charge from the nitrogen. So that formula is K3N. And for K plus I minus, 1 plus 1 minus, they already cancel, so just Ki. Now, this is the same type of question, except that now instead of giving us the actual ions, they're telling us the elements. So we have to go to that extra step of checking the periodic table to see what is the ion that will be formed and then putting it together. And they actually have us do this stepwise. They tell us they want the cation that is formed and the anion is formed and then the compound. So you can kind of see it stepwise. So sodium is in group 1. It forms a +1 charge. That is the cation. Sulfur is in group 6 here, so it makes a -2 charge. That is the anion, S2 minus. And then if I have the sodium +1 ion and the sulfur -2 ion, in order to get a compound formula where those charges are equal and opposite, balanced out, I need 2 sodiums to balance out 1 sulfur. So this is going to be Na2S. For potassium and nitrogen, potassium's in column 1, so it's just +1, K plus. Nitrogen is in group 5, so it makes a -3 ion. That's N3 minus. And when I put these two together, I'm going to need 3 potassium ions to balance the charge from 1 nitrogen ion. So that's going to be K3N. For aluminum and iodide, aluminum's in group 3, so it has a +3 charge. Iodide is in group 7, so it has a -1 charge. When I put those two together, I'm going to need 3 iodine ions to balance the charge from 1 aluminum, so that will be Al(I)3. And finally, lithium and oxygen. Lithium is over here. Li, it has a +1 charge because it's in group 1. Oxygen is in group 6, so it has a -2 charge. So we have lithium plus and O2 minus. Hopefully you can see if I put those together, I'm going to need 2 lithiums for every 1 oxygen. And it's going to look like that. By the way, it is not an accident that they are always listing the metals first and the nonmetal second. In every ionic compound, we always list the cation, which is the positively charged ion, which came from the metals, first. So cation is always listed first, then the anion. So it goes in that order. They gave us those elements in that order. We're expressing those ions in that order, and then we always put the formula in that order. So it would be incorrect to call this NK3, for instance. It would always be K3N instead. Okay, this is a particularly challenging problem just because there's a lot to submit, and if you miss one tiny thing, they won't tell you what it is that you missed. So pay very careful attention to yours. You will have different ions than I do. So the important part here is not to copy what I have, but to carefully trace the steps of what I do. All right. So we want to make a compound using lithium and chlorine, a compound with lithium and nitrite, compound with lithium and hydrogen carbonate, lithium and sulfite, and lithium and phosphate. And we're going to go in the order that's given here, and we're going to put all of those compounds in. And of course, like we've done previously, the charges have to cancel. So if I have a lithium 1+ and a Cl1-, then I just need one of each, and the formula for that will be LiCl. For lithium and nitrite, this is 1+, that's 1-. I just need one of each, so I need LiNO2. By the way, when you're drawing the formula or writing the formula of a compound, you never include the ion charges or anything like that. The whole thing gets put together. There are no charges shown, just the ratio of cations to anions that you need to make that work. Now we have lithium with hydrogen carbonate. Lithium is +1, hydrogen carbonate is -1, so I just need one of each. There we go. And now it starts to get tricky. Sulfite has a 2- charge. Lithium is +1, so I need 2 lithiums to make that work. So Li2SO3. And for this last one, phosphate has a 3- charge. So I'm going to need 3 lithiums to balance that out. So I'm going to have Li3PO4. So just like that, you can see how if I miss one tiny piece of information or neglect to put in a comma, for instance, it's going to dock me for that. So be very careful and precise when putting these in. All right, I'm going to do the same thing now with copper. Copper 2+. So if I do copper 2+ with chlorine 1-, I need 2 chlorines to balance out the charge from the copper. So CuCl2. And I'm done. Now this is a little bit more tricky when I'm looking at polyatomics. Copper 2+ and NO2-, that is nitrite. I'm going to need 2 of these nitrite ions, but I cannot just say CuNO2, because that makes it look like I've got 22 oxygens, and that doesn't make any sense at all. So instead, what I'm going to do is put that whole thing in parentheses, because I need 2 of the nitrites. They come in a bunch. I'd put a 2 there, okay? I did not have to put the chlorines in parentheses because there was just one atom in the chlorine ion, but I do have to put the nitrite in parentheses because there's more than one atom, so I need to make sure that I indicate there's multiples of that whole bunch. Now I'm going to have the same issue with HCl3-. I've got copper with 2+, HCl3 with a 1-, so I need 2 of those bicarbonate anions in order to cancel out the copper. So Cu, and again, I have to put this in parentheses because there's more than one of them. Just like that. Next, sulfite has a 2- charge. Copper has a 2+ charge. They are equally matched, so CuSO3 is all I need. And finally, phosphate with a 3- and Cu with a 2+. This is where it gets a little bit harder to just eyeball it. Cu +2, PO4 -3. I clearly have more negative charges than positive charges, but if I add 2 coppers, then I'm going to have 4 positive charges and 3 negative charges, so then I'll have more positive charges. So if I add another phosphate, then I'll be at -6, and so on and so forth. So one of the easiest tricks when you're stuck with something like this is to put the charge as the other ions' subscript. And that gives you a multiple that works. I'd have +6, -6, that would cancel. So Cu3, PO4, and now I have to put that in parentheses because there's more than one of that whole cluster of atoms that makes the ion, 2. So Cu3, PO4, 2 is what's going to do it. Just like that. Finally, barium is going to look exactly the same as this, because this is 2+ and that's 2+. So the ratios will be identical. I don't know if I can copy and paste that, but that'd be convenient, wouldn't it? So I'm using barium instead of copper. The subscripts did not translate. Barium here, barium here, barium here. Looks like I missed the first part. Your ions might be different than mine, so I would not just automatically assume that that's going to work for you. But I had a 1+, a 2+, and a 2+, so I knew that the ratios that I formed with these ions would be the same. I would just be using a different cation. Next, which is one of the following is a correct ionic formula? That means that 3 of those 4 are incorrect. Let's have a look. We look at our periodic table. We know that potassium's in group 1, so K has a charge of +1. And hydrogen sulfate is one of our polyatomic ions that we memorize, and it has a charge of -1, so I'm going to need one of each. That would be KHSO4. That looks good. So that might be it. But let's check. Calcium's in group 2, so it's 2+. And PO4 is one of our polyatomic ions, which has a charge that we memorized to be 3-. So if I had 2 of those, then 2 times +2 would be +4. And that would still have a -3, and that does not cancel, so that does not work. NaSO4, if I'm using the sodium ion with the sulfate polyatomic ion, which we know has a charge of -2, we would need 2 sodiums for every 1 sulfate. That is not the formula we've got there, so that doesn't work. And then aluminum's in group 3, so it has a charge of +3. And oxygen is in group 6, so it has a charge of -2. So if we put that together, we would need a formula of Al2O3, and that's not what I'm seeing. So this is the right answer. It's a good exam type question. You could probably expect to see something like that on the exam. All right, and last, if element G could react with sulfur to form an ionic compound using the formula GS2, then what would the charge on G be? Now what you need to do is go backwards according to what you know about the way that ionic compounds form. This must be neutral by definition, otherwise it's not a compound. So because I know that this is neutral, and I know that sulfur is in group 6 and it has a charge of -2, then I have 2 sulfur ions times a charge of -2. That means I have a charge of -4 that must be canceled out by this cation. And since there's only one of those, then that one cation must have a charge of +4. We're going to be doing a lot more of that on our next homework assignment. So this is a little bit of a good intro to that for you. Okay, I hope this was helpful, guys. Have a great day.